Hello, this is the first presentation addressing VHDL design matters. It is also the first presentation in a series addressing lower complexity designs, which I chose to call first part, as opposed to another series that we will call second part, where we will look into higher complexity designs. Right now, however, we will look into what's in the VHDL description. So after watching this presentation, I hope that you will be able to explain what sections are needed to build a VHDL description for synthesis purposes. Please notice that we will be focusing on the content of Chapter 1 of our recommended book for this course. There are a few introductory rules that I would like you to keep in mind. The first of which is that VHDL is case insensitive, meaning that you can either use upper or lowercase letters, it doesn't matter. And it is also free formatting, meaning that you can use spaces and blank lines at will. Finally, any identifiers, that is to say the name of the signal, for example, they must start with a letter, but they can use any of the 26 letters in the alphabet, and then you can also use digits and the underscore symbol. Now, as you can see in this slide, the VHDL description essentially contains three sections, which we will look into in the following slides. The first section starts with the library line, and the second section addresses the entity, and the third and last section addresses the architecture. In this case, we are looking at the description of a one-bit comparator, and I think that you will find this description to be very much self-explanatory, since what we are doing here is we are actually just listing the two product terms for this truth table on the right. By the way, this example is on page 2 of the book. Now let's start by looking at the first section, as I have just said, which specifies the library and packages that are needed for this description. Libraries allow you to store commonly used packages, which in turn enable you to store commonly used data types. These two lines are needed in this case because we are using a special data type called standard logic, as you see here, as we will see in the entity declaration. So let's move on to the entity declaration, which is the second section, and which contains information about the inputs and outputs of our circuit, as well as their data types. In this case, they are all of the standard logic data type. Let me tell you that operators and data types are the subject of a following presentation. In this case, the inputs and output are defined with standard logic, and this data type is defined in the standard logic 1164 package. This data type actually comprises 9 values, of which 3 are synthesizable. Those are the logic 0, logic 1, and the theta for high impedance, which the third one is not used in this case. So let me still tell you in relation to the entity that we can look at this as a black box description that gives us information about inputs and outputs, but not on how they relate to each other. Their relation between inputs and outputs is actually explained in the architecture section, or architecture body, is where we will find the function of the circuit. The operators referred here are the usual logic operators, so we have the OR, and NOT. And their usage shows a direct relation to the truth table on the right. An important thing to notice at this point is that this description contains 3 so-called concurrent statements. And concurrency is a key concept in VHDL design. It refers to things that will take place in parallel. What this means is that these three statements are not executed in sequence, but rather in parallel. Actually, the way this works is that whenever one of the inputs in any of these statements changes state, for example, if I0 or I1 change from 0 to 1 or vice versa, then the statement is activated and the expression is evaluated. So if I0 changes state, these two expressions will be re-evaluated simultaneously. And this is very much what happens in a schematic diagram, where when an input changes state, it will propagate through the various circuit branches in parallel. This is how it works. Thanks for your attention.